Hello everyone, welcome to the Electronic Work Instructions Lunch and Learn. Today's presentation will feature using NX Movie Output for assembly instructions, output in process drawings, NX file outputs, display setting considerations, video production tips, and internet resources. For assembly movies, you want to always prep the assembly first. You want to save a working documentation copy. Use the Show and Hide by Type command to quickly filter on screen points, datums, planes. Assign colors to components. Set your rotation point. Use a simple background color. And make your arrangements and reference sets in advance. The default movie file output is in your My Documents, My Videos folder. Here's an assembly prep example. So here we have an aircraft assembly, and we're going to go through and just take the basic steps. You can see a coordinate system and some datums there. Don't really want to see those, so we're going to just show and hide by type, get rid of the datums. Zoom to fit, see that everything fills the window. Make sure the WCS isn't showing, unless you want it to show. And if you need to set an object color or two, that's pretty easy. Do that with the object display command. And finally, set your background. We're just going to use a simple white in this one. One other thing you can do is visualization. If you get faceting in your models, you can turn the detail up. There will be a slowdown for this. There's a pause while NX redraws the screen, but it'll clean up all the round edges. You will want to do a little bit of on-screen manipulation, spin the model around, make sure nothing's getting clipped off, and that the speed of movement and everything is appropriate for your project. That assembly looks good. Time to move on. Having prepped your assembly, you'll want to make sure and understand the right movie settings. For the Capture Area command, you want to make sure and choose the graphics window if you only want to see the NX parts and none of the interface. The other two options will either capture the whole NX window or your computer desktop. Smoothness is 6 to 8 frames per second is about like a cartoon, so it'll be an optimal quality and size. Smooth enough to be visually pleasing, but not overly smooth. 10 to 15 frames per second will be seen as smooth and fluid, and 15 frames per second is highly likely to be overkill. For compression, you just use the default. Your external movie tools, if you're using them, will compress this differently. If you're just using the NX movies and putting them on the network, the Microsoft Video 1 selection is fine. Playback speed is useful when you want the video to play back at a different rate than it's recorded. You may want to show something complicated over a period of time, or you may want to shrink an operation down into some conceptual level. Either way, you can choose from the 5 options there. As recorded, which is real time, very slow, very fast, and the ones in between. And now we have an example of the different movie settings. So we have this assembly. We're going to go ahead and set the capture area to graphics, put the frames up at 15, and we're going to choose 1:1 as recorded. So we'll go ahead and start the movie. And we'll title this one Normal. So now the movie's recording. Just spin the model around. Bring it back into view, stop the movie. There's the next one. Go ahead and we'll choose the very slow setting. And repeat the exact same operation. So we'll just title this one so we know which one it is. And the movie is started. So we'll spin the model, bring it back into view, stop. And you can turn those checkboxes off if they annoy you. And then lastly, we'll do very fast. So here's a ×4 playback. And we'll cut the frames on this because you really don't need as many on a super fast playback. So once again, title of the movie, this will be the fast one. And spin the model, bring it back into view, and stop. So now we'll compare the actual movie files. Here's the real-time one. And you notice my cursor passing over highlighting objects. You can turn off your selection filter to get rid of that if you have that trouble. Here's the next one. This is the very slow one. So you can see here we could have actually asked for more frames because the 15 may almost not have been enough. But there's the slow playback. Even though they were all recorded about the same speed, you get a very different playback. So lastly, here's the fast one. So it's actually quick enough we can zip through it 2 or 3 times in the time that it took the others to play. Some tips on this. Object selection can get in the way of the movie. Obviously, you saw that in the ones that were just before. It is often quicker to record taking something apart and record the movie backward to show assembly. Fast movies need fewer frames. Record things in chunks so that you can assemble them into a final production. And create your sequence, then edit excess steps out. Assemblies can have multiple sequences to them, and the main sequence commands are insert motion, record camera, assemble to make component visible, disassemble to make a component hidden, and insert pause to allow voiceover time. In the next example following this slide, we'll go ahead and step through those, but fundamentally, sequences are just breakdowns of these different operations. So you're either moving the camera, placing a component, or making it appear or disappear from the screen. So here's an example of an assembly movie instruction. So first thing we'll do is we'll pick the sequence, and we're on sequence 1 using the new sequence command. And we're going to record the camera right out of the gate, put a small pause in right out of the gate so the movie starts nicely. Then we'll pick the insert motion command, and you notice you get a little toolbar up there. So the method is you select an object, you pick what you want to do. In this case, we're going to move it. And if you've made a motion, you want to apply the motion, and then pick the object again, and we use the disassemble command to get rid of it. So one more time, record the camera. Pick the object, there's the move it someplace to show it's assembled. Go ahead and select it again, disassemble it, and repeat for the other objects. You can move objects in groups as well. They're being shown one at a time here just to highlight the concept, but you could just as easily pick multiple things at this stage. There's no requirement to do them one by one. And we'll change the view. Be sure and always save the camera when you do that, or you'll get a jerky video. And we'll pick that last screw out and disassemble it. Now moving on to the plenum. Take another camera snapshot. We'll take the plenum, move it up out of the way, slide it over, and use the disassemble command to give it some appearance of coming off the screen. And finally the gasket. And the same thing applies. We'll just move it over, use the disassembly command so that it'll appear to pop out on the screen. We're going to play this one backwards as a movie to make an assembly video, but we're going to record it as a disassembly video. So you see there's 170 frames. You can choose whether you want to play backwards or forwards. So here we're going to hit the play backwards button. And next we'll build all the frames. This is what it's going to make a movie of. So the gasket gets inserted. The plenum fits over the gasket. And in go the screws. Now we'll go ahead and fast forward to the end again. And this time, we'll ask NX to record a movie file for us. So we can just call this something. Call it the assembly video. And now NX will go through and render all the frames into a movie file that you can use later in your production application to build your work instructions. Or you can just play the movie file. Now that the movie file is complete, here's the output from NX. And there's the finished AVI file that you can email to somebody, place on the network, and use in a kiosk for a work instruction. And there go the last couple of screws, and the assembly movie is complete. So now we're going to capture a sequence step as arrangement. The other thing you can do with these sequences is as you build them, the assembly will be in certain states you may want to make a drawing of. You can hit the arrangement button, capture as arrangement, to bring these into drafting as standard 2D drawings in addition to making movies. And here's an example of doing that. Arrangements from sequence on drawing. So here we have an assembly. And we're going to look at the model views. We've got one there set for drafting. And you can see the assembly here. There are 4 arrangements. These were pre-made, but they show the assembly in different states. So now we're going to make a new drawing. And we'll take the base view command, pick an arrangement, choose the drafting view that we made in modeling so they're all consistent. And these arrangements were captured during the sequencing using the capture sequence as arrangement command. And so there you can see those getting put on the drawing, assembly in various stages, and from there, using the combination of model views and arrangements, it's fairly easy to put together documentation for assemblies in different phases. Next up, we've got a sheet metal bend process. This one's a little complicated. The steps are convert or create a sheet metal part. Then you want to generate your flat pattern view. Then create unbend operations to show the sequence of bending. Label everything just for your general sanity. Use the extract body here command to create in-process models. Create reference sets for each bend sequence. Then we're going to create a new parent to create a process assembly. And we'll create one assembly instance per bend step. On the drafting, we'll create a new assembly drawing of process assembly model. We'll create the new view of the process assembly, and we'll orient and scale at that point. Then you copy paste the views to quickly create all the view steps, and then you edit each view, hiding all the components in the assembly except for the one that highlights that particular process step. Repeat for all views, and then update the drawing. So we'll see all that play out here. Here's an example of building a sheet metal bend sequence. You see the sheet metal part here has a lot of different models showing. And start with a sheet metal step, extract a body, and then bodies were extracted for bend A, bend B, and bend C, and a flat. Actually, bend C is missing. So you can kind of see there's what A looks like, and there's what B looks like. And then C, we don't have a body for yet. So we'll go ahead and do that right now, just to show you how that's done. So we'll take the operation, use the extract body here command. It'll pop it right in the right place in the history. You'll want to label these just to make sure that you're doing the right thing later on. So now that we've got them all, there's all the bends. And we'll go ahead and just make those visible. And we'll leave the flat till later. And so we'll make those all shown. There's your completed model. Now we want to use reference sets. And you'll notice a lot of them are already done, but reference set C still needs to be done. So we make a new reference set. Call that bend C. And we'll make sure and pick the body for bend C, so that that reference set contains the right data. Next step is to create a parent assembly. This is the process assembly. So when you use the create new parent command, it'll take this model with all of its reference sets in it, and it will embed it in an assembly, which we're going to call sheet metal process. And the process assembly exists just to hold assembly instances that each contain the process step we want. So we're going to go ahead and make a copy of the sheet metal instance, and we're just going to paste these into the process assembly. And we'll do a few of them here, 4 or 5, just to show the steps. So right now that's just paste, paste, paste. And then for each one, make the reference set active. So we'll do one for bend A, do the next one bend B, the next one is bend C, and then we'll go ahead and do bend D, and lastly the fully formed. So now those are all prepped and ready to go. Each instance in the assembly represents one process step. So now we can move on to drafting. So we'll make a new drawing. And the drawing you make of the sheet metal process assembly, not the sheet metal part. So here we're going to cancel these view wizards. And we'll go ahead and expand out our assembly tree, hit the base view button. And here's where we want to orient the view, so we can show the process steps really clearly. So flip this thing over. That'll probably work. So we'll accept that. Then drop the view onto the sheet. And again, we just want to copy paste real quick. So we'll just take this one, make a copy, and we'll paste it. And then just repeat that to get the process step views we want. So there's another paste, another placement, and a paste. And then one last view up on the top here. Since we had 5, we'll just put it over here. So now, got all the views created. Use the edit command on the view to go through and pick all the hidden components. So this is where the magic is. You pick your components and you want to hide everything, and then use a control pick here to unpick the process step that needs to be seen. So there's the step for that one, and we'll repeat for the bottom view. So same thing, we'll edit, hidden components, pick all the process steps, and then unpick the one that works for the view. And we'll do a quick update just for a sanity check. So there we can see that one. Update. It shows that process step. Come down and do this one. Same thing. We'll do an update. And it shows its process step. So we'll go back through and just very quickly do the others. So another edit. Hidden components. Unselect the one that you need. Middle mouse right there in the windows, what's going on. and then we'll get to the last two. And this general technique can be used for lots of things. You could do machine parts, castings, profiles, lots of stuff this way. It just happened to work out really nicely with sheet metal. Now we'll go ahead and update the whole drawing. All the process steps show up. And now you can zoom in and see the different bends. So some of the bends are made in that view. Some of the different ones are made in this view, and so on and so forth. And then just as a final touch, we'll go ahead and put the flat pattern on there. And in this case, you want to do the sheet metal part, not the process assembly. So we'll go ahead and pick a different part, sheet metal part. And the flat patterns work off of model views, so that's really easy. We can just pick the flat pattern model view and drop that right on the drawing. And there we've got the beginnings to a pretty good sheet metal process drawing. This is a quick list of the file outputs available in NX. For vector files, you can get some vectors into PDF like 2D drawings. You can use an AutoCAD DXF or DWG. And then there's CGM, which is an older format, but very useful because it is scalable and it supports colors and line widths and a variety of other things. It requires a plug-in for Microsoft Word or something like CorelDRAW or Inkscape to use. The bitmaps, we're pretty familiar with those. JPEG, PNG, TIFF, bitmap. Those are great for pictures out of the graphics window, and TIFF in particular can be used for large drawings. Mixed mode PDFs happen out of NX sometimes as part of FEA reports, and we saw the movie file output in the form of AVI during this presentation. There's some internet resources I want to tell you about. This presentation was done on Microsoft Expressions. It's a free download. It has really great codecs. It's simple to use, and it can do good, very effective screen captures. The one downside is it does require a separate audio editor. I use Audacity for this presentation, and that's an audio capture program that's really pretty capable. It's got effects, mixing, all the basic things you need. Inkscape is a vector graphics CorelDRAW-like program. It can do CGM files. You can use it to create title slides and other annotations for your work instructions. And then there's GIMP, the bitmap graphics program that's similar to Photoshop. It has a lot of capability, fairly easy to use. All of these can be found as Windows installer downloads, usually at sourceforge.net. Just search on them. And then we go to NX display settings. There are times if you see artifacts, missing pieces, or poorly defined edges, be sure and set the detail to fine or ultra fine. Size NX desktops for consistent recordings. You can also sometimes get your capture program to size the window. Microsoft Expressions does that. Keep your background simple, black or white. They compress better and they render better over various kinds of video codecs. For colors on your models, select high contrast colors. Use the whole color wheel. So red, blue, green, yellow. They're easy to distinguish and make for good instructions. And use extra fine or ultra fine on visualization detail when you see the edges of things are polygonized. Lastly, we've got some production tips. And those are basically, you want to record in chunks. You can assemble those in Expressions or some other program to create a longer movie. Use the standard Microsoft tools where you can. The slides in this one were done with PowerPoint. You play your recorded movie back to voice it over. Describe what you're seeing, and then you can take the slack out of the voiceover when you're done and line it up with the video just fine. That saves you from having to make a 2 tracks to get that done. Record from NX for clean movie assets, and record with Video Capture Tool if you're doing a how-to type presentation like this one is. And thank you very much. Direct all questions to doug@acuityinc.com. Visit our website.